All right, so let's look at this problem here. We're going to do 8.2.13/T. We have a association claim that the mean annual cost of food for dogs and cats are the same. Okay, so if the claim is that dogs and cats are the same, the cost, then that is a two-tail test. So just right off, we can tell the answer to A. Let's see here. What is the correct claim below? Well, that they're the same, that they're equal. Okay, so I mean, it tells us that in that first sentence. Okay, and also it tells us that it's a two-tail test because they're saying that they're the same. It's not saying that they're less than or greater than. So we have the alternative hypothesis here. And the null hypothesis is always this right here. And then which hypothesis is the claim? So they're equal because, yeah, I mean, that goes with the previous answer. So the null hypothesis is the claim. And so that's A. So we're good there. Now, part B, find the critical values and identify the rejection regions. So the critical values, we will want to use the T calculator in StatCrunch. Oh, wait, I'm not using, I don't know why I have this calculator up. So, let's just move that right there. This up. Bring this down a bit. Okay, so we have stat calculators T. Since we're dealing with mean and we have a T distribution, as you can tell with the solutions here, we're dealing with a T distribution. So that's how we find the critical values, is with this calculator. So the degrees of freedom is n minus 2, or sorry, it's the min of the two sample sizes. So it's n1, the min of the sample size is -1. So that would be that one, smaller sample size, 9. And so that would be 8 degrees of freedom. And then we have find the critical value and identify the region. We want between, since we're dealing with a two-tailed test. And we have an alpha of 0.01. So if we have an alpha of 0.01, we want both tails to add up to 0.01. And keep in mind that we're measuring the area in between. So that's what we want to eventually get to. So we want to divide alpha, the two tails, into 2. So that would give us 0.01 divided by 2, which is actually, we just need, you don't have to deal with that because alpha is the sum of the two tails, so the area in between is just 1 minus alpha. So that's 0.99. And we compute. And that's how they get negative 3.355 and or 3.355 here. And select the correct rejection region below. So the rejection region is the non-shaded portion. So it's less than this value here and greater than this value here. And so keep in mind that the critical value is T sub 0. So this is negative T sub 0. This is T sub 0. Okay. So it's all the critical region is T values. It's T values less than the negative 3.355 and T values greater than 3.555. If you look at this table, so less than this value and greater than this value. So that would be option C. Okay, find the standardized test statistic. That goes into the actual hypothesis test. remember the calculators, either a normal calculator or a T calculator, is dealing with the critical regions on the parts of the hypothesis test. So we're done with the critical regions, so we're done with the T calculator. We're ready to go into the hypothesis test. So notice that we're doing a T-stat, and we have 2 samples. And we have the summary. With summary, so that tells us, I mean, based on that chart on the top, with dogs and cats and the mean, standard deviation, and sample size, we have the summary. And so we can fill in the mean of sample 1, so that's 240. And standard deviation of 40. And 15. And sample 2 is cats, 205, 36, and 9. And we're doing a hypothesis test, not a confidence interval. And we want a 2-tail test. And so we've gone over this before, but the mu1 equals mu2. If we move mu2 to the left side of the equation, it's mu1 minus mu2, and that's this right here. And we would be left with a 0 on the right side. So, I mean, almost any type of test like this, you always have 0 on this side. I don't think I've ever really seen an example where there's been anything but 0 for this type of hypothesis test. For this specific hypothesis test, that is. Okay, so that's it. We're ready to compute. And we have this chart here. And as you can see, we have the T-stat here, rounded 3 decimals. We round that 3rd decimal up because that's the 6 after. So we round the 3rd decimal up because we want to round to 3 decimal places, as mentioned here. And then comparing this to the critical values, it's not located in the critical region because it's in between these 2 values. So that is a fail to reject. So at the 1% significance level, there is not enough evidence, and you're pretty good at figuring out the conclusion. So yeah, so there we go. It's just that one single blank to fill in. So you're going to have different numbers. You may come up with a whole different result. Even you may even reject. I'm not sure because I don't know what numbers you have because they're always different. So so use what I've mentioned here to help you out on 8.2.13/T. So hopefully this helps out. Let me know if you have any other concerns. I know I ran through this pretty quick, but you can rewind a bit and then rewatch it the video. So I don't mind going pretty quickly through this. Okay. All right. Yeah. Let me know if you have any other concerns.